Thank you for joining Indium Software's webinar entitled Mobile Test Automation in 2 Weeks, presented by Arvi Ashokan, Head of Test Automation at Indium Software. Hello, everybody. My name is Glenn Greenblatt. I'm Vice President of Sales for Indium Software, and I work out of our Princeton, New Jersey office in the United States. Indium Software is a mature, offshore solutions-driven testing services company. Let me tell you a little bit about our presenter. Arvi has 16 plus years of experience in software testing. He is well versed in manual and automation testing with expertise in implementing robust automation frameworks. He has worked for noted clients such as Google and Amazon. He holds a double master's degree in MCA and has an MBA. Without further ado, here's our very own Arvi Ashokan.
Thank you, Glenn. Welcome, everyone. Mobile test automation in 2 weeks is an interesting topic. I'm sure that you are all curious to know how this can be accomplished. Well, in the next 30 minutes, we'll see how it works. This slide illustrates the mobility trends in 2015 and onwards. I would like to break down the slide into 3 different categories: mobile sales and reach growth, mobile usage, enterprises' adaptation to mobility. If you look at statistics 1 and 2, global smartphone use have reached 1.3 billion now and expected to grow more than twofold by 2017, which is going to be 3 billion. It is more likely that India would soon overtake the USA as the second biggest consumer of mobiles. Moving on to the next important category of discussion, which is mobile usage. When you look at statistics 3, 4, and 5, it is evident that mobile web is already dominating desktop web. It is primarily because of millions of apps getting launched every day. Most importantly, about 50% of the mobile apps don't have a desktop version at all. Would you believe if a stat says that average time spent by a human on mobile is 2 hours and 21 minutes? The average user engages with his mobile 200 times a day and is expected to rise exponentially. In this context, the usage of mobile apps just doesn't stop on consumers. It has also been a boon to the employers to make their operations more efficient, productive, and successful. Across all industries and segments, global and national brands are spending more time on researching, studying, and implementing mobile strategies to gain competitive edge. It is expected that by 2017, 100% of employee apps will be built. That's a great news again, isn't it? I guess it's going to make our jobs easier. The global enterprise mobility market opportunity is expected to be 140 billion by the year 2020. Enterprises will spend 15 to 20% of their IT budgets on mobility compared to less than 5% at present. So this rapid rise in the usage of mobile phones and tablets has fueled the mad rush of venture funding in consumer-facing mobile companies. This research draws the attention to why investments are preferably done in emerging markets. It is not hard to understand as they contain 80% of the world's population and create about 50% of world's GDP. So folks, I believe these major trends in mobility bring a lot more hope for business. Today, when there are thousands of mobile apps in the market, app developers need to be able to come up with apps that stand out among the rest. How do we ensure we hook up users to our app? Though we can have the name, look, color, interface, description, and the feedback attractive, what matters is the most is the experience the user gets using the first app for the first time. How do we ensure the app succeeds and overcomes the expectations? Let us look at the way the current apps are built. Using MADP, the Mobile App Development Platform, or MEAP, the Mobile Enterprise App Platform, in both these platforms, a mobile app can be developed using a third-party script, which can in turn compile or develop the iOS, Android, or Windows-specific versions of the app. Off-the-shelf mobile apps are ready-made ones available for your needs, and the custom apps can be developed for your very specific needs. Of course, the application type would be another choice you'll have to make, whether it's a native web or an hybrid. You can see some of the most popular MADP and MEAP providers. Some of the typical challenges: it is more of customer driven and are cloud-based services. The production or release cycle is generally shorter with more of hardware, software choices, and multiple mobile carriers with lack of standards. So what are the barriers to mobile testing? Most of the times, it lacks the right process or methodology, as it's a newer technology relatively. All device combinations aren't available for testing. Regular functional testers perform mobile testing. How many experts do we have in mobile testing? Not many. Setting up the in-house environment could be a pain area owing to the fact that there are multiple combinations of device hardware and operating systems. Lack of right tool for testing and time for testing is inadequate due to the faster releases. To complicate the situation, there are several automation tools in the market, the popular ones being Silk Mobile, Appium, C-Test, Perfecto Mobile, Device Anywhere, Keynote, etc. And the challenge is how to select the best fit tool. Challenges in mobile automation. Diversity. The most important challenge is diversity. Diversity in device manufacturers. There are diversified mobile operating systems in market, diversified browsers to test the applications in, and different mobile interfaces available for the applications. With all the combinations, it really becomes very complex. In order to automate mobiles, you may have to jailbreak or root the device to gain access to the kernel and other operating system related core areas. But this may brick your device and you may never use your services of mobile vendor permanently after that. The source code of an application may be required for automation, or alternatively, you may have to add a few libraries before compiling a build in order to gain access to the application objects. Applications may render differently in multiple sizes. For example, the objects you have on a larger screen may not be present in a smaller device screen. To handle such dynamics becomes challenging when it comes to automation. Native applications built on a specific hardware cannot be automated outside of that hardware. Hence, we need to modify or patch the signature on the application to make it work on multiple hardware, and patching the browsers for a web application isn't possible. Any feature that is specific to a device cannot be generalized in automation. And iOS automation involves cost if we are using open source tools. What not to automate? I have seen automation engineers trying to automate several areas. Ideally, they shouldn't be automating. Here are some of those which should not be automated. Anything that has to be visually verified, like the layout, color, video, image, etc., should not be automated. Automation can aid in a way. It can capture the image and add it in the report for a manual verification later. Usability testing, which will require a human to understand the usability aspect of an application. Unstable application. I've seen many automation project failures due to an unstable application. We should remember that a stable application is the prerequisite for automation along with the written test cases. Any test we run one time only or occasionally executed test cases, the automation effort isn't worth it. Plus, it would additionally require maintenance efforts, particularly if we execute the same script after several months. ASAP testing or some feature that has to be tested immediately should be tested manually and not automated. Anything that has to be tested with high priority should be manually done unless you already have the test scripts automated. Native wrapped third-party applications. There are apps built using third-party applications like Flash, Unity gaming platform, etc. These applications could be available for mobile using native wrappers. Though the native applications can be automated, the third-party layer inside it will not let it automate. Ad hoc testing cannot be automated due to its unstructured nature and unavailability of test cases. What is a light automation framework? Light automation framework is a variant of test automation framework where it is simple and easy for a layman to use it and execute the test cases. The framework is modularized based on the utility functions and ensure these are independent and individual entities that interact with each other. The framework should be configurable for executing the tests, and the tests should be controllable. A light framework provides the basis of test automation and simplifies the automation effort. Apart from that, it addresses the three key factors of automation: maintainability, reusability, and extensibility. What are the architectural considerations we should keep in mind while designing a light framework? Make it easy for the end users, functional testers, and business analysts to configure, customize, and execute the test cases. The framework should support multitude devices, multiple mobile platforms, and support all the mobile application interfaces. It should be flexible to work on any mobile automation tool and cater to any language supported by any of the automation tools. Language or test automation tools should not be a constraint in an automation framework. The framework should be built in such a way that it can run the tests in parallel and supports execution on cloud-based services like Browser Tab, Source Labs, cross-browser testing, etc. Reporting should be a key feature to look out for in a framework. The reports should not only be simple, it should be easy to understand and fully customizable as per the client need. The framework should support data-driven testing. Maintenance of multiple versions of the framework for different customers could be challenging, but if you plan it in advance, this can be overcome easily. Having all the general features of the framework in the trunk of your version control system and client-specific customizations in the branches is a general approach to go about it. So let us move on to the demo of an advanced framework. Here everything is configurable. The sheet we currently see is the suite level configuration. This is the place where we configure all the settings with respect to the current test execution, like the URL, credentials, location of the test data file, the various timeouts at page and element level. We also have settings for continuing the remaining steps upon failure. The email related configuration is for sending out an email with an attachment of the test results at the end of execution. The other settings are with respect to the reports, database configurations, etc. The second sheet is the grid configuration, where we specify the target machines or devices for parallel execution. In the current case, we have 5 target environments, including IE and Chrome on a Windows desktop, Safari on iPad, Chrome on Android, and Firefox on Mac executing on cloud. We are executing on browser stack, but the framework also supports other cloud-based services. There is an execution flag for selecting or deselecting a target machine for execution. Next sheet is our test case setting, which is used for selecting or deselecting the test cases for current execution. The three simple test cases for the current demo are login, a flight reservation scenario, and the logout. Here comes our test data configuration. The test scripts consumes the data from this sheet. If there is a need for someone like a business analyst or a manual QA person to execute the test case with a different set of data, they can do so by making changes on this sheet. For data-driven approach, just add a new data row for a particular test case. With this introduction, we are kicking off the execution. When the execution starts, we can see the scripts running in parallel on all 5 environments. On your left side, you will see what's happening on the cloud, an iPad running on a Mac desktop. And on the right, you will see the browsers and Android connected to a Windows desktop. Here it is. So we are starting the execution here. Momentarily, we should see the browsers getting launched on all the 5 parallel targets. So it has launched the browser on iPad on the cloud. It has launched the 2 browsers on Windows. It is yet to launch the browser on Android. So the execution is, it has started on cloud, iPad, and on the browsers. It has launched the browser on the Android as well. So whatever data that's getting populated here is all from the data sheet. So if we make changes in the data sheet, automatically the test will pick up the data changes and key in the data as per the new changes. So on the iPad, the execution is complete and the browser has closed. And on the Windows, both the browsers, the execution has completed, and on Android, it just got completed. There's only one target environment where the scripts are still executing. It's on the cloud. So the execution is complete on the cloud as well. We can see the message, the script execution is complete. So for every test execution, the framework creates a timestamp based folder, and inside the folder, we have all the 5 target subfolders: Cloud 1, Desktop 1, 2, iPad, and Moto G. So this is a top-level dashboard report of all the executions as a snapshot. So let me open up the Moto G. So here, it has executed 3 test cases. It took 43 seconds for the execution. This is the flight reservation scenario, and you can see the test data as well as the test steps. And each of the test steps looks pretty simple and easy to understand. So this is the login scenario and the logout. So on the cloud, it took 55 seconds for execution, but the reports look pretty similar to what we saw in the earlier report. The framework also creates exhaustive logs. Every step that happens at the framework level or at the application level is recorded in the log. This can be handy and useful for troubleshooting any crashes. So that was one of our advanced framework. Uh, when you look out for a framework, you must look out for the one that can sit on top of any automation tool, support any scripting language, and customizable for your needs. You can clearly see as we move up in time in the maturity increases, productivity also increases, while the defect leakage rate comes down and savings start increasing. In general, the ROI in test automation is attained anywhere between 9 months to 2 years. I'm sure you all will agree to it. Well, it's not. If the framework is taking care of all the key considerations mentioned in today's presentation, we need not wait for that long to get the returns. It can happen in just few weeks. We can clearly see there is a decrease in the test execution time from manual to automation. Similarly, there is a significant reduction in automation execution time while using a light framework like iMobi, which was demonstrated some time back. This is enabled through multiple executions in parallel. When we use a mature framework, we get better ROI on test automation. The automation also addresses the key quality attributes like maximum requirement coverage, very low defect leakage, and unified scripting process for many mobile devices. We have noticed 35% saving in resource arbitrations in 3 years, early detection of defects, reducing the rework by 15%, and lesser leakage to production, leading to lower costs of quality. There has been an increase in testing efficiency, leading to reduced test cycle time of up to 30% and steep reduction in test execution time enabled through parallel execution. Here comes the end of webinar. Hope you find it informative. I'll open the floor for question and answer. You can post your questions on questions tab. I'll try to answer as much as I can. Here is the first question. How much time is required to develop such a framework? Well, the answer is considerable amount of time. However, automation framework like iMobi, which is available for free, can be substantially used to, it can substantially reduce the initial investments in terms of cost, effort, and time. There's one more question here. Can I execute tests in parallel using UFT C-test plugin? How many parallel executions can the framework support? This is a very good question. We have limitations in some of the tools, especially tools like UFT can execute only one execution at a time, and it cannot execute the tests in parallel. So if we have such a limitation in the tool, the framework cannot support that kind of feature. On the other hand, if we take you know tools like Silk Mobile or Silk Central, which Silk Central with the help of Silk Mobile can execute the scripts on multiple machines or devices at the same time. So is the case with Appium and Selenium Grid. So that can also execute the scripts in parallel. So it all depends on the limitation on the tool, and the framework does not have any limitation, but it depends on the tool limitation. There's one more question here. How can we maximize the device coverage using a framework? So to answer this, finite number of devices are available and can be set up in a lab. We can procure those and set up the devices in the lab. But almost every device is available on the cloud. So we can build the framework in such a way that it can be leveraged. Uh, uh, it can leverage the cloud-based services to cover more devices. This concludes our webinar. Thank you for joining. We will share the webinar recording shortly. Please email your specific questions or write to us for further information at webinarsupport@indiumsoft.com. Thank you again.